Okay, so we're going to compare some rectangles here. We've got a photograph in the scale of 1 to 1 that is 4 centimeters long and 2 centimeters wide. And I've put these numbers in to make it nice and simple so that it's easy for you to be able to calculate the difference in perimeter compared with the difference in area. So when you're doing a question like this, try and do numbers that make it pretty easy for yourself. So let's look at the perimeter of rectangle A. It's 2 times 2. We've got 2 lengths of 2 centimeters, one here and one here, plus 1 times 2. There are 2 1 centimeter lengths here and here. So the perimeter of A is really easy to work out. 2 2s are 4, 1 2 is 2, equals 6 centimeters. What about the perimeter of rectangle B then? Well, that's easy to work out as well. You've got 4 centimeters, you've got 2 lengths at 4 centimeters, and you've got 2 lengths at 2 centimeters as well. So that equals 8 plus 2 2s are 4 equals 12 centimeters. So how does the perimeter change from B to A? Well, the perimeter of B divided by the perimeter of A would be 12 centimeters divided by 6 centimeters, which is 2 times. So it's 2 times as large. The perimeter of B is 2 times as large. 2 times as large, the perimeter. What about the area then? Well, the area of A would be the length times the breadth, which is 2 times 1, equals 2 centimeters squared. The area of B is also 2 length times breadth, which in this case is 4 times 2, which gives us 8 centimeters squared. So what is the area of B divided by the area of A? How much larger is the area of A than the area of B? We would get 8 centimeters squared divided by 2 centimeters squared. Anything divided by itself cancels, so all of the units disappear, giving us the answer of 4. So the area is 4 times as large. So even though we're comparing exactly the same rectangles, we can see that the perimeter is only twice as large, but the area is 4 times as large. Why is that? What's the difference then? What's the connection between perimeter and area? Well, when we're measuring area, we're measuring a length multiplied by a breadth, which is going to be 2 squared. 2 squared. So the area would be 4 times as large because it's 2 squared compared with the perimeter. Let's look at the rectangle A to C then. What happens there? We'll know the perimeter of A. What about the perimeter of C? Well, the perimeter of C is going to be the length 8, and we've got 2 of them, plus the length 4, and we've got 2 of them. 2 8s are 16, 4 2s are 8. So the perimeter of rectangle C is going to be 16 plus 8 equals 24 centimeters. How much bigger is perimeter C divided by perimeter A? Well, it's going to be 24 divided by 6, which is going to be 4 times as large. 4 times as large. So I would expect the area to be 4 times as large, but squared when we're calculating the area. So I would expect the area, without even doing any calculation here, the area I'd expect to be 4 squared. I would expect it to be 16 times as large. So let's do the calculation and see if we're right. We'll make a little bit of space up here. Let's calculate then the area of C. The area of C is going to be 8 times 4. 8 4s are 32. It's going to be 32 centimeters squared. If we're now going to compare the area of C divided by the area of A to see what ratio we get, we'd get the area of C is 32 centimeters squared, and the area of A is 2 centimeters squared. Centimeters squared cancel. 32 divided by 2 is 16. So 16 times as large, which is what we would have expected to get because it was the same as what we got with the previous AB comparison. So AC uses the same principle. So the area is always 2 squared times larger, 4 times larger compared with the perimeter. And that's a very interesting and useful thing to remember about areas. That if the area is doubled, if the length or dimensions are doubled, the area is always 2 squared. If the area is 3 times long, if the length is 3 times longer, then the area is going to be 3 squared, 9 times larger.